if the temperature rises, what do you think this means about the particles' speed and how far apart they are? What do you think happens to the speed of the particles as I heat them up? Remember the thing we did out in the quad? Oh, what a good answer. Okay, so it's moving faster because it's taking that heat energy. And what else do? They don't just move faster, they start to expand. I love that word. Which means spread out. We're done with A. We've generalised what's happening in A. It's still a solid. Now we'll go back to the answer that was given before, because that's the answer for B. B is at 0 degrees. Does anyone know what that special value is? 0 degrees for ice. What does it mean? Freezing point if it's water and melting point if it's ice. Good. So this is where now the heat energy doesn't increase the speed of the particles. Instead, what do you think it's doing? Not slowing them down, because then the temperature go down. That was a good idea. That was the other option. So the particles are going the same speed now. This is the really hard one, so I'll teach you this bit. Here, rather than speeding the particles up, what the heat energy is doing is actually breaking the bonds between the particles. So it's letting the solid particles escape so that they can now move more freely. So now it's turning from a solid into a, well done, a liquid. Okay, so we call this, Olivia's right, the freezing point, but we also call it the melting point. I'm just going to underline that because it's such an important word. The heat energy doesn't speed the particles up anymore. It just turns them from a solid to a liquid. And that's it for B, that's all we have to say. So the particles are going the same speed, but now they've turned into a different state or a different phase. So therefore, at C, all of the particles should be in what state? Not quite, that would be E. Okay, jumped a little bit too far, but that's all right.
Liquid?
Liquid. So it is a liquid. So I start this the same here. And then we say the same sort of thing. As it's heated, we notice that what's rising? The
temperature.
Good. Which means the particles are getting
Faster.
And the distance between them is getting
Longer.
bigger. And then suddenly at D, it starts to, what was that? I heard it.
Boil.
Boil, well done, and so on. So I'm not going to finish C off either for you. Your job now is to use this idea here, so what was taught, to finish off of what's happening in C, what's happening in D, and what's happening in E. We'll stop there.